Hello, Math 2 students. Today we are going to go over how to take out a greatest common factor, or GCF, out of polynomials. All right. So, we're going to spend quite a few lessons on going over how to factor. Now, the first thing you always check for before you factor anything is, does this polynomial have a greatest common factor or a GCF? So today we're going to work on practicing finding the greatest common factor and factoring it out. So, first example here, so what is the greatest common factor? It's the largest factor that can divide a pair of monomials or terms of a polynomial. So the example they gave us here is find the greatest common factor of 24 and 36. So what you can do here is think about all the factors of 24. What are all the ways or the pairs of numbers we can multiply to get 24? So we've got 1 and 24. We've got 2 and 12. We've got 3 and 8. And then we've got 4 and 6. Okay, so those are all of my factors for 24. My factors for 36 are going to be 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then you can get it by doing 6 times 6. So how am I getting all of these numbers? I'm just starting at 1 and I'm like, okay, can I do 36 divided by 1? Yes, I can. 1 times 36, right? Can I do 36 divided by 2? Yes. 2 times 18 is 36. Can I do 36 divided by 3? Yes. 36 divided by 3 is 12. So we do 3 and 12. Can I do 36 divided by 4? Yes. 4 times 9. Can I do 36 divided by 5? No, I'm going to get a decimal. Okay, so if you go on your calculator and do 36 divided by 5, you get a decimal. So that tells you that 5 is not a factor. So then you go on to 6. Does 6 work? Yep, because you can do 36 divided by 6. All right. So basically what you're doing is you're just coming up with all of the different pairs of numbers that you can multiply to get that value. Then when you're trying to find the greatest common factor, you need to find the biggest number that they both have in common. Okay. So if I'm looking at this list of numbers, you can see that both of them have 12 and 12 in common. They have smaller factors in common, right? They have 2's in common, and they have 4's in common, and they have 6's in common. However, it's the greatest common factor, so you need to go for the highest number that they have in common. So your answer here would be 12. All right, so that's how it works when you have just numbers, okay? Now let's talk about when we have a polynomial like this, okay? So first, let's look at the 12 and the 8, okay? Let's list out all of the factors of 12 and then all the factors of 8, all right? So the factors of 12 are going to be 1 and 12, 2 times 6, so I got 2 and 6. 3 works, I can do 3 and 4. And then you can try 5, but it's not going to work, right? So you can try 5. 5's not going to work. So these are going to be your factors of 12. All right. Factors of 8 are going to be 1 and 8, because I can do 1 times 8. 2 times 4. And that's actually it. Those are the only ways I can make 8 is 1 and 2. 1 and 8 and 2 and 4. So looking at these lists of factors of 12 and 8, we have to find the greatest common one, meaning the biggest one they have in common. Yeah, they both have 2's in common, but the biggest one they have in common is 4. So my greatest common factor between 12 and 8 is going to be 4. Then I also need to look at my variables, okay? This first term has 5 x's. This second term has 4 x's. Basically, you can take out up to 5 x's from this guy and up to 4 x's from the second guy. And you're going to have to go with the least number of x's, because this guy has 4 to give, this guy has 5 to give. So you're going to pull out 4 x's. All right, so bear with me here. We determined that we're going to take a 4 out. And then we determined we're going to take 4 x's out. So we're going to, our GCF here, all right, is going to be 4x to the power of 4, okay? So when you pull this factor out, essentially what you have to do once you determine your greatest common factor is you are going to divide both of these terms by your GCF, all right? So 12 divided by 4 is 3. This should be a 4. And when we divide powers, we subtract them. So 5 minus 4 is 1. So we get a 3x there. Then I divide this guy by 4x to the 4th. I get 2. And 4 minus 4 is 0. Well, x to the power of 0 equals 1. So it's like 2 times 1, which is just 2. All right. So this is how we would factor out a greatest common factor. Now, I want you to keep in mind, you can actually check your answers by distributing back out. If I were to distribute this, okay, I get 12x to the 5th plus 8x to the 4th. Notice how I end up with the same thing that I started with. Now, distributing back in to check doesn't check to make sure that you took out the greatest common factor, but it does ensure that you at least factored properly, okay? So it's not completely foolproof, but it is going to help you catch errors along the way. All right, let's go ahead and try another one. How about this one here? So first, let's look at our coefficients. We've got 15. So let's list out our factors of 15. We've got 1 and 15. 2 doesn't work. We can't do 15 divided by 2. But 3 does work. We can do 3 and 5. And then 4 doesn't work because you can't do 15 divided by 4 without getting a decimal. So our factors for this guy are going to be these numbers. Then we've got 18. So 18 is going to be 1 and 18, 2 and 9, and 3 and 6. All right. 4 doesn't work and 5 doesn't work. And then after 5, we end up back at 6. So once you kind of start repeating numbers, you're done. So looking at 15 and 18, my greatest common factor is going to be 3. All right. So I know I'm going to pull a 3 out. Now I have to decide how many x's I can pull out. The first term has an x squared. It has 2 x's to give. The second term doesn't have any x's to give. You have to go by the whichever term has the least amount of x's. That's how many you can pull out. So guess what? The 18 doesn't have any x's, so you can't pull any x's out of this. So my greatest common factor here is actually going to be 3. So I just divide both of these terms by 3, and I get 5x squared plus 6. And that would be my, that would be what this would look like when I take out my greatest common factor. All right. And again, we can check by distributing. We got 15x squared plus 18. So we know we did it right. Or at least we know we factored whatever we took out, we at least took out correctly. It may not be the biggest, but it's a good way to check. All right. All right, let's try this next one here. Now, this one's trickier because we have 3 terms, okay? So we're going to have to go ahead and list out the factors of each of these values. So for 18, we've got 1 and 18, 2 and 9, 3 and 6, and that's it. Because 4 doesn't work and 5 doesn't work. All right. Then for 6 is easy. We got 1 and 6, and then 2 and 3. All right, because I can do 1 times 6 to get 6 and 2 times 3 to get 6. Then we've got 24. All right, so for 24, I can do 1 and 24. I can do 2 and 12. I'm running out of space. Oh, no. I can do 3 and 8. And I can do 4 and 6. So now looking at all of these values, the greatest common factor appears to be 6. All right, at least in terms of the coefficients. All right, so I'm going to pull a 6 out, and now I got to figure out how much of the variables I can pull out. So if we look at the first guy, he has 4 y's to give. My second guy has 3 y's to give, and my last guy has 2 y's to give. So the maximum number of y's that I can pull out is 2. So I'm going to pull out a y squared. So this is my greatest common factor. So I'm going to go ahead and divide each of these by my GCF. So I'm going to do divided by 6y squared. So negative 18 divided by 6 is going to give me a negative 3. And remember, when we divide powers, we subtract. We do top minus bottom. So we're going to end up with, not an x, a y to the power of 2, because we do 4 minus 2. Then again, we're going to do 6y squared. 6 divided by 6 is 1. And 3 minus 2 is also 1. So we end up with 1y, which, if you recall, we would just write as y. And then we divide this by 6y squared. 24 divided by 6 is going to be 4. 2 minus 2 is 0, so we don't have any y's left on that guy there. And of course, we can go ahead and check our answers by distributing. All right, so I want you to keep in mind, this is my actual answer. Okay, like if I said, take out the greatest common factor, factor out the greatest common factor, this would be your answer. I'm just showing you how you can kind of check to see if it's a reasonable answer. So we get minus 18y to the 4th plus 6y cubed plus 24y squared. And if we look, it appears that we did a good job. All right. Let's see. Let's do one more here. So if we look at these guys, all right, this guy is a coefficient of 1. Now, the factors of 1 are literally just 1, okay? The factors of 5 are 1 and 5, and the factors of 22 are going to be, we do have 1 and 22, and then we have 2 and 11, and that's it, all right? So, if you notice, the only factor the coefficients have in common is 1. And if you notice, literally all of these have 1s, right? If 1 ends up being your greatest common factor, you can't really pull a 1 out, because when you divide by 1, you get what you started with. So if the smallest coefficient you have is 1, you're not going to take you're not going to divide the coefficients really by anything, all right? So the greatest common factor is 1. We can't do a ton with that. However, we can look and see if we can pull any x's out. This guy is 3, this guy is 2, and this guy is 1. We can pull 1x out. So we're going to divide all of these by x. We get x squared plus 5x minus 22. All right. All right. I'll leave it at that. Nice job.